degree of accuracy. That means up to 2 decimal, or 3 decimal, or 2 significant figure. All this. Okay, now regarding that one. Oh, you are not getting? Oh, sorry. Okay, okay. Yeah, I forgot to. One more. According to my opinion, roll number 12. Okay, you can send me personally also if you think okay this answer sheet also a good one. Okay, now I'm not telling the others are bad. Okay, now but not good. All are good. Okay, but according to you, that means it will be. I wants to know you are checking of other solutions or not, other answer script or not. Okay. Just check it and just send me only one email roll number, not to in that group, to me personally. Okay, that means you have gone through all the solution, all the answer sheet. Okay, now is it visible now? Screen I have shared. Okay. stopping criteria. Guys, is it visible? Okay. Stopping criteria. So note 1, 2 note actually as per our discussion. I have told you that 2 notes today we will discuss. First note 1. Okay. The note when you should stop this iterative process. Okay. 2 iterative process. That is Gauss-SEIDEL and Gauss-Jacoby. We have to study over here. So Gauss-Jacoby and Gauss-SEIDEL. Okay. For these 2 methods, what is the stopping criteria? The number of iteration k recorded depends upon the desired degree of accuracy. So if somebody asks what is the stopping criteria, you can say this one. It's more than enough. Okay, now upon the desired degree of accuracy. Okay. If an error is be tolerated in the sth iteration, then the test for convergence is given by xi s plus 1 minus xi s less than epsilon s. There is actually s value, that is the error. It should be less than the error. This outcome should be less than of this error, estimated error. Okay. So now k greater than equals to s. What is the meaning? This xi representing the vector x1, x2, x3. What is it? Or you can say, see this x1, xi is the solution, okay, of the set. So there are say distance vector is this one, x1, x2, x3. Okay. Then this xi represent actually x1i, x2i, and x3i, like that. Okay. This is the ith iteration. Okay, or ith solution. Okay. So that is actually xi represents, it is a vector. Okay. So now this is the stopping criteria for the for the given 2 iteration formula. One is Gauss-Jacoby and Gauss-SEIDEL. Okay. So next one is, this is stopping criteria. Next one regarding the convergence. Okay. So that note basically for both. Okay. That Gauss-Jacoby and Gauss-SEIDEL. Okay. What is note 2? Note 2. Okay. Okay. So fundamentally this one for actually Gauss-Jacoby only. Okay. But it can be extended for that Gauss-SEIDEL also. Okay. The Gauss-Jacoby, okay, iterative formula, iteration, okay, converges if and only if. Okay, if and only if, I double F. Okay, if and only if, I double F. Okay, if the system of equation is strictly diagonally dominant. Okay, diagonally dominant. You have already studied this one, na? What is the meaning? Diagonally dominant. What is the notation? That is, we have already discussed, correct? AII j equals to 1 to n a mod of Aij, correct? What is the condition? I not equals to j. That means here a11 should not be there, or a22 should not be there in the right hand side. Okay, this is actually sorry, this is, if you consider equals to, then it is diagonally dominant, correct? So now the convergence criteria, this is the convergence criteria. Okay, na? Convergence criteria, that is converges if and only if. Converges if and only if means convergence criteria. What is that one? Now that one is, now here it is, just check, strictly greater than. Fine. So these two are the notes for the iterative method, these two iterative methods. Fine. Okay, next. So next one is Gauss-SEIDEL method. Okay, pages, new page. Okay. So what is the difference between the Gauss-Jacoby and Gauss-SEIDEL? Then it will be easy to memorize the methods of Gauss-SEIDEL. Okay. Gauss-SEIDEL method. Okay, fine. So sorry. Sorry, madam. Okay, for 3 unknown and 3 equation. I have already told that the Gauss-SEIDEL is the modified form of Gauss-Jacoby. Okay, so before we start this discussion regarding Gauss-SEIDEL, just tell me the working formula. Okay, or iterative formula. Sorry, what is the working formula of Gauss-SEIDEL? Let us see how many are able to answer. Okay. Iterative formula or working formula? Working formula. Okay, na? Actually, that should be for the 3x3 matrix. 3x3 matrix only. So x1 k plus 1, right? x2 k plus 2, and x3. I will write a little bit this side. Okay, na? Left hand side. Okay. So x1 k plus 1 equals to x2 k plus 1 equals to x3 k plus 1. Okay, so 1 by a11. What is the rest part? Yeah.
Minus a13 s3 k.
Good. Second one. A21. Okay. X1 k minus
a23.
Yeah, x3 k. Fine. And final one. This part I know, first part. Rest part I don't know. B3 up to this one. Minus
a31 x1 k.
Yeah, x1 k.
a32 x2 k.
A32 x2 k. Okay, so, but sometimes it is really tough to identify what I am writing. Okay, that time you should ask me. Okay, I will rewrite that one. Okay, And remember, if you have any doubt anywhere, okay, you should not be silent. Okay, you should ask me, and any time, not even in this class, other time also. If you have any doubt, anytime you can ask me. Okay, na? You know my number, WhatsApp also. If I am not replying means, okay, you just wait for some times. That time maybe I was busy. Okay, I will reply you. Okay, after some time. What about this is Gauss Jacoby? Okay, now. So what will be the Gauss SEIDEL modified one? Okay, just see. Okay, say it is the second iteration. Let us see, or first iteration. Okay, first iteration or second iteration, whatever may be the iteration number. Okay, when you are finding say x1 1 first iteration say, okay, then or second iteration, let us consider the second iteration first. Okay, x2 second iteration, x1 2. What is your answer? The a1 1, okay, b1 minus a12 x2 1, okay, minus a13, it should be different color, oh sorry, okay, a13 x3 1. Fine. For this at the second iteration, I have written. What about x2 2 then? a22 b2 minus a21 1, okay, sorry 21 x1 1, correct, or x1 1 or what, x1 1, correct, minus a23 x3 1. Fine. This two. I will not write the x3. Wait for the x3. Okay. So now you just see in this iteration, second iteration, first iteration already you have the answer x11, x1. So this pen actually gone. Okay, x1. Just see one drop is coming. x2 and x3, these are known, okay, before we start this second iteration. Okay, now so x1 2, when you are finding x1 2, okay, then x2 1 it is already there and x2 3 already there, that is fine. Now when we start this one, when we start this second iteration, okay, and in the second iteration when we start to find x22, then what is the answer? Now a22 fine, b2 minus a21 x1. So x1 means you are using this one from here, but if you check, okay, x1 value is already another updated value is there in that same iteration. So the underline one, you just see the red underline. Okay, now we are not using this one. Okay, now what this one we are actually using from here, that yes tick mark. Okay, but if we that is x1, this one is updated one, correct now. So instead of using the old updated x1 value, okay, we can change with this new updated x1 value. So instead of 1, sorry, we will write here 2. Clear? But x3 we don't have any update value here over here. So x3 we have to use from here only. Fine. Okay. Now x32 equals to a33, fine, v3 minus a31 x1 1 according to Jacoby method. Okay, na, minus a32 x2 1 according to this one is Jacoby method now, correct. Now if you check that x1 1, that is actually you are taking from here, and x2 1 you are taking from here to evaluate x3. Is it clear? It is actually according to the Gauss-Jacoby method. But we have already another updated value x1. x1 to x2 2. But instead of that one, we are using the old one, previous one, exact previous one, and it is actually the previous iteration value. So since we have already another updated, use that old one, we will use this one. Are you following me? Okay. Then if this one is clear, so what we are doing actually in the same iteration, okay, we should not use the previous iterations. If you have in the same iteration, if you have the updated value, that one we should. Unknown at that iteration, the second iteration. Okay. When you are finding the next one, x2 2, that time x1 is use this x1 value, old one, first iteration. We should use this one, x2 1. Fine. So now I will erase this, all this discussion. Fine, that is enough. Okay. Now working formula for the Gauss-Jacoby method is here. Correct. So as per our discussion, okay, we can update this one. Okay, this one, the Gauss-SEIDEL working formula. Gauss-SEIDEL working formula. Okay, how? Now this is a kth iteration. That means general. So x1 k plus 1. This in this iteration, it is first time actually we are going to use, or we are going to find x1. So we don't know the x2 and x3, the outcome in the same iteration k iteration. But previous iteration k minus 1 iteration, we know the result. So these two we have to use from. Okay. Fine. Now x2 plus 1. Okay. This one is known in the same iteration, correct? Updated one. Then what is the recorded changes? Instead of k, what we have to write?
K plus 1.
K plus 1. Fine, k plus 1. Can we change this one x3?
No, sir.
No, since we
No,
don't
sir.
k only from this one, from the previous one. Okay, now so we can't apply this one, but this one we can use here. Is the one. Now when we are finding the x3, next solution, next variable solution in the same iteration, correct? So this k plus 1, k should change to k plus 1. Fine. And this x2 also known here. So this k1 we should use from here, the outcome of first solution. X2 is also here, correct? So this one. So what should we change? K plus 1. Fine. So now I will rewrite the changes again. K. This iterative formula remaining same. First I will change one by one. This one will change. Okay, right. This one also will change. What are the changes? You just see I have written in different k plus 1, k plus 1. What is k plus 1? Here it is also plus 1. Here it is also k plus 1. Any doubt? So this is the earlier one, if you replace this one, this one, and this one, then this working formula is actually is, but the new updated one is the of the Gauss-Jacoby iterative method. Okay. So called iteration formula. Iteration formula of Gauss-Seidel is given by this one. This one. This is the working formula. What is the stopping criteria? Stopping criteria already I have given today itself. Okay. Now. So mathematical that concepts form mathematical formula. You know that mathematical concept. You know what is the criteria. Today we have already discussed this one today. So next one is the Gauss-Jacoby convergence. This is the working formula for Gauss-Seidel. Next, so Gauss-Seidel one is same. Okay, that is actually stopping criteria. Okay, stopping criteria. And note 2 is that is actually convergence criteria. Okay, so I think you no need to discuss that too again. The problem, okay, solution of a system of linear equation using Gauss-Seidel method. Okay, same problem we will consider the previous problem. Okay, documents. Yeah, this one. No. This is recorded today. Fine. Same problem. Okay. This one we have already discussed based on the method Gauss-Seidel. Okay, Gauss-Jacoby. Fine. This problem, same problem. I will rewrite this one. Same problem. You know the solution also. Okay. So I'll go to this one here. So now, okay, you can see the difference between the Gauss-Jacoby and Gauss-Seidel. Okay. Solve the system. We can consider different problem also, but later first we should check what is the difference between these two. Okay, now, of linear equations using Gauss-Seidel iterative method. Iteration method. Okay. This one. Same problem. Okay, what is the problem now? X1 plus x2 plus 4x3 equals to 9. 8x1 minus 3x2 plus 2x3 equals to 22. 4x1 plus 11x2, okay, minus x3 equals to 33. This is the solution. Okay, now here it is stopping criteria is, okay, correct, okay, correct up to 3 decimal places. correct up to 3 decimal places. Up to 3 significant figures. Sorry, significant figures. What is the difference between significant figures and 3 decimal places? You already know, correct? How many significant figures are there here?
4.
4 here. No, it is 0.0002. How many significant figures?
1.
1. Correct. What is the decimal places? Both are 3. Correct. Fine. So no need to discuss. Fine. Okay. So here it is correct up to 3 significant figure. Okay. So now solution. Fine. Solution. Okay. Same procedure. Okay. The system of equation is not diagonally dominant. As only one you have to show, no need to show all. Okay. As mod of 1 not greater than equals to, okay, mod of 1 plus mod of 4. Okay, fine. So F1 case is enough, okay, for this one. Now what we have to do? Now we rearrange the system as follows. Correct now. So this one will be third, this one will be first, this one will be second. Okay. So and hence I am not writing here 3 1 2. You should not use my technique. Okay now. You should not write 3 1 2. You should write the equations. Okay. This system, the system of equation is diagonally dominant. Since mod of 8 greater than mod of -3 plus mod of 2, so that is 5. That implies 8 greater than 5, that is fine. Mod of 11 greater than mod of 4 plus mod of -1, that implies 11 greater than 5. And finally mod of 4 greater than mod of 1 plus mod of 1. So that implies 4 greater than 2. Fine. Okay. Now the iteration formula of Gauss-Jacoby. Now the iteration formula of Gauss-Jacoby, Gauss-Seidel is write down x1 k plus 1 equals to 1 by 8, 20 plus 3 x1 k minus 2 x3 k, okay, x2 k plus 1 equals to 1 by 11, okay, 33 minus 4 x1 k plus 1, okay, plus x3 k plus 1, x3 k plus 1 equals to 1 by 4, okay, 9 minus x1 k plus 1 minus x2 k. Fine. These are the iteration formula of Gauss-Seidel method. Correct? People are not here. I think so. Is fine? No. Check it. Intentionally, I have written 2 mistakes.
So in second formula, x3 is k only, sir.
Yeah, fine. Anything else?
And in third formula, x2 k plus 1.
Yeah, correct. Now it's fine. This is the formula. Okay. Okay. Now write down. What is the initial value? Go through the problem. This one is what is the initial approximation?
Not given, sir.
Not given. Okay. Fine. So what we have to do? We have to consider. According to your choice, you can consider that one. Okay. We take the initial guess. Correct now. As follows. Okay. As follows. So x10 equals to 0. I'm giving it right now. Okay now. x2 0 equals to 0 and x3 0 equals to 0. You know, the Gauss SEIDEL actually it is faster convergence. The properties is faster convergence. That means it will converge fastly compared to the that convergence rate of Gauss Jacoby. If you I have considered 0 0 0. Otherwise, okay, in the last discussion we have considered 1 1 1. Okay. Otherwise, you have to do lot of iteration. But here it is. If you consider little bit away from the original solution also, okay, then also it will converge fastly. Okay. So now, what is the first iteration? You can choose different also. Okay, now as per your choice. Okay. So now the first iteration. I don't know the solution. Now you have to answer it. Okay, na? Then only I can write. But that formula I know 1 by 8. Okay, it is written over here. So plus 3 into 0 minus 2 into 0. This one you have to write. You have to find. Okay, 1 by 11, 33 minus 4 into what is the answer? You don't know, correct now? Minus plus 1 into 0, that one I know. What is the answer? And now x3 1 is 1 by 4. Okay, 1 by 4, 9 minus 1 into something minus 1 into 1 into something, this one. This two double underline means this here you have to put the numerical values, okay, of x1 and x3. So what is the answer? This one, first one, x11 20 by 8, correct now? It is 0, it is 0. So 10 by 4, so 5 by 2, correct? 5 by 2. You should have pen, a calculator, otherwise it will be problem. 2.5. Now it is 2.5. Should I change the color? So it is 2.5. So answer here it is 2.5. Now what is the answer? 1 by 11, 33 minus 4 into 2.5 plus 0. So what is the outcome? 2.0909. Since it is 3 significant figures, so that means 2 are first one, 1, 2, 3. So another 2 should be there. That's good. 0909. Okay. So now here it is x1. I can write this one 2.5 and 2.0909. Fine. So what is the answer now?
1.1022, sir.
Just repeat 1.1022.
1022.
Okay, this one. So now second iteration. Okay, second iteration here itself I will write the second iteration. Second iteration. x1 x12 place may be less, so I will write here x12 equals to 1 by 8, okay, 20 plus 3 into not 0, it is 2.5 minus 2 into x21, that is 2.0909. I have written wrong, correct? So this is not 2.5, okay, it is 2.0909 minus 2 into 1.1022. x22 1 by 11, 33 minus 4 into 2.5, this answer, okay, this answer, this one should be written here, okay. Now again, okay, plus, okay, 3.0085, so 3.0085, and now 1 into, okay, 1 into, that is actually x2 means x1 and x3 will be the same, 1.1022, okay, that one. So this one also I will highlight it through underline red. What is this one? Then only I will find x3. Fine, good, very good. Now x23, I will write here, okay, now one of that I will read is this one, okay, this one here I will write, okay, and color is different, so it will be fine. x32 is 1 by 4, 9 minus 1 into x1, correct, now x1 is means this one, that red underline one, 3.0085, okay, this one here it is, not this one, okay, then minus, okay, sorry, plus 1 into, again underline, red underline, okay, red underline one. So this one, what is the answer? So this red underline means it is x22, that means this one, okay, so 2.0061, this answer, not the previous iteration answer. So what is the answer now? 0.9963, okay, 63, not 263, okay, fine. So third iteration, you just complete third iteration, then we will stop, okay. So third iteration, in the next one I will write the third iteration, okay, na? Third iteration, the third iteration, fine. I will write the formula, x13, okay, 1 by 8, 20 plus 3 into x22 minus 2 into x32, x23, 1 by 11, 33 minus 4 into x13, okay, plus 1 into x32, 2, and x3 3 equals to 1 by 4, 9 minus 1 into x13 minus 1 into x23, not 2. Okay. Fine. I have written only the iterative formula. So now you tell me the answer one by one. You can write here 1 by 8, 20 plus 3 into x2. x2 value as x22. What is the answer? 2.0062, correct? 2.0062. Previous one. 2.0061, sorry, 61, then 1.09963, correct. Next one, not 62, is 61, okay, fine, 61 minus 2 into, okay, 2 into 0.9963. So what is the answer? Here it is 1 by 11. Should write in different color. 1 by 11, 33 minus 4 into x1. You tell me this answer first. 3.0032. Fine. So 4 into 3.0032 plus 1 into x32, previous one, it is same, 0.9963. What is the answer? Very good, fine. And now this one, 1 by 4, 9 minus 1 into x13. You just see this underline one, 3.0032. Okay, not like this one. Oh, not like the other one. Okay, now. So earlier one, 1 into 1 cross 1 into x2, x23. So this one, 1.9985. What is the answer? 95. Okay. So if it is correct up to 2 decimal places, we'll go previous one. Okay. Correct up to 2 decimal places, you just see this is fine. This is also fine. And this is also fine. 2 decimal places. Correct now. These 3 are the answer. In the iteration 2, I will make again red box. 2 decimal places, correct up to 2 decimal places. And now next one, if you go there, here it is, this is fine, matching, this is also matching, this one only 0 0, it is not matching, you have to go through. Okay, what is our original solution? Original solution 3 to 1, correct now? So if you do this next iteration, you will get the answer, sure. The next iteration will give you the answer. So only the, no, fine. Sorry, just 1 minute. Oh, it is, no, only this 2 is not matching, this one, fine. Okay, so one more iteration, 4th iteration, you will get the solution. Okay, so we will not study that one anymore. Okay, now so 4th iteration you have to do. 4th iteration, you can stop after that one. Okay, now 4th iteration you will be getting, say, let us the answer is x14, x24, and x34. Okay, surely 2 decimal places, correct up to 2 decimal places. If it is that type of criteria, then you can stop there. But here it is correct up to 3 significant figure. Okay, the problem is here it is 3 significant figure will match, here also it will match, but in this case you have to go 3 decimal places. Okay, 0 is not a significant figure for that one. So 999, previous one, it is 996. Okay, I will change the criteria then. Okay, correct up to 2 significant figure or 2 decimal places, that will be better. 2 decimal places. Okay, 2 dp. Okay, so next you have to find the fourth iteration and then you can stop. Okay, I think you will get that 2 decimal places, same answer. Okay, next. Okay, now I will give you 2 homework, no need to submit. Okay, for practice purpose only. Okay, homework, practice purpose. Instead of writing homework, you just for practice. Okay, now solve the system of linear equations. Okay, equations using Gauss, Jacoby and Gauss SEIDEL. Okay, method, Gauss SEIDEL methods. Practice purpose only. Okay, so 2 problem, first one and second one. First one is this one, 10x plus y plus z equals to 12, 2x plus 2y plus 10z equals to 104, 2x plus 10y plus z equals to 13. Second problem, okay, 1.2x1 plus 2.1x2 plus 4.2x3 equals to 9.9, 5.3x2, sorry, x1 plus 6.1x2 plus 4.7x3 equals to 21.6. Final one is 9.2x1 plus 8.3x2 plus x3 to 15.2. These 2 are okay. So I think it will be better if you not use this one. Already you have studied this one. Already you have done one problem. Okay, now have completed one problem using this one. So okay, Gauss SEIDEL method only. Okay, practice only, no need to say. If you have any doubt, okay, you can discuss with me, no problem. That's all. Can I ask any arbitrarily anyone? Okay, now. Okay, let us see. Those are actually in the last class. I have not responded from few people. Okay, now I will check with them only. Roll number 33.
Yes, sir.
Okay, but what is the difference between Gauss SEIDEL and Gauss Jacoby?
Sir, in the second one, sir, we will have in second equation k plus 1, sir.
Okay, for everyone or
No, sir.
Second?
Only
Hello?
for two. Only
No
for
one should
two.
leave the meeting. Okay, you people should be here only. Okay, na? Okay, tell me, better. Yeah.
Only for 2-1, sir.
Only 2-1.
A2-1.
Okay. And what about the third equation? If it is 3 cross 3 matrix, correct na?
Yes,
Yeah.
sir. For two A31 and A32, sir.
Okay, for both. Okay. Okay. However, you should not answer with that coefficient. You should answer with the variable. Okay. Okay.
Okay,
Roll
sir.
number 20. Okay. Roll number 20.
Yes, sir.
What is the convergence criteria of Gauss-Seidel? Not Gauss-Jacoby, Gauss-Seidel.
What, sir?
What is the convergence criteria? That means we can say that, okay, the solution will be exist.
We should have three significant figures.
Hi, what you are answering better. What is the convergence criteria? Okay, you should be online. Just wait. Roll number 9. Okay. Roll number 32. Today also roll number 9 is absent or not responding. It's not good. Okay. Roll number 30. Roll number 23. Roll number 11. 1. Okay. Roll number 12. Just see the scenario. Okay. 1, 2.
Sir, roll number 12 present, sir.
12. Okay. What is the convergence criteria of Gauss-Seidel?